7.4 is the factor theorem. Again, the fact that it's a theorem, who cares? But it is something you need to know. So for a polynomial p of x, x minus c is a factor of p of x if and only if p of c is 0. X minus c. So if we look at, is x minus 6 a factor of p of x equals, x to the fourth minus 6x cubed minus 4x squared plus 24x. Well, what's being subtracted? 6 is being subtracted. So we're going to see if p of 6 is 0. So if we do 6 to the fourth minus 6 times 6 cubed minus 4 times 6 squared plus 24 times 6, this is all calculator work, that equals 0. So then yes, x minus 6 is a factor of that polynomial. Is x minus 2 a factor? It shouldn't be 120, it should actually be 100. And so, let's see. 2 is being subtracted, so let's check p of 2. So 2 to the fourth plus 2 times 2 cubed minus 25 times 2 squared minus 26 times 2 plus 100. If you put this in your calculator, you could do it by hand if you want. Either way, this equals negative 20. So is x minus 2 a factor? No, because if you plug in what's being subtracted, your c, I guess, you don't get 0. Here's another way to do this. So find a third-degree polynomial p of x with integer coefficients whose zeros are negative 4, 1, and 2. So the way we do this, we have p of x equals, it's third degree, so we have 3 factors, and we have our zeros. So x minus, well, first one's negative 4, times x minus 1 times x minus 2. And typically we would not write it that way, right? We would write it as p of x equals x plus 4 times x minus 1 times x minus 2. Here we're looking for an equation for the third degree polynomial function p graphed below. So here's what we know. We need to deal with our a. Okay, so when given the y-intercept, so up here we were not given a y-intercept, right? But here we are. When given the y-intercept, solve for the leading coefficient. The leading coefficient is our a. You could technically call it whatever you want, but I'm going to call it a. So we have p of x equals sum a times x minus, well, let's go through here. This is directly between negative 4 and negative 6. That's negative 5. So we have x minus negative 5 times x minus, this is directly between negative 2 and negative 4. So that x-intercepts negative 3. And the last one is 2. So times x minus 2. So p of x equals a times x plus 5 times x plus 3 times x minus 2. What do we know? Well, that's our y-intercept, and it's 0, negative 60. So I know that p of 0 is a times negative 60 plus 5. Sorry, we're not putting in negative 60, are we? X is 0. So p of 0 equals a times 0 plus 5 times 0 plus 3 times 0 minus 2, and that's going to be our y value, negative 60. So that's a times 5 times 3 times negative 2 equals negative 60. 5 times 3 times negative 2 is negative 30 times a equals negative 60. Divide by negative 30, a is 2. So then p of x, now we just put our a back in. So we have 2, and then we still have x plus 5, x plus 3, x minus 2. And that is factored form because we see the factors. If we want to do standard form, we have to multiply through. So we have 2 times x plus 5 times x plus 3 times x minus 2. And so you essentially just have to split it. So let's do 2 times x plus 5, which is 2x plus 10, times x plus 3 times x minus 2 is x squared minus 2x plus 3x, so plus x minus 6. If we multiply here, we have 2x cubed plus 2x squared minus 12x plus 10x squared plus 10x minus 60. And if we simplify this, we have 2x cubed, sorry, we'll put our p of x back here too, okay? So our p of x equals 2x cubed. 2x squared plus 10x squared is 12x squared. Negative 12x plus 10x is negative 2x minus 60. And that right there is standard form. Okay, so do you see the factors or has it all been multiplied? You see the factors, it's factored form, otherwise it's standard form. So here's an example. We have a y-intercept, so we'll need a, and we know it's a third degree polynomial, or the x-intercepts are negative 8, 12, and 13, and we want to find the function. And again, we have a y-intercept, so we need a. So let's see, we have p of x equals a, because we have the y-intercept, times x minus negative 8 times x minus 12 times x minus 13. So we'll rewrite this as a times x plus 8 times x minus 12 times x minus 13. And since the y-intercept is negative 624, it means we have the point 0, negative 624. So then p of 0 is going to be a times 0 plus 8 times 0 minus 12 times 0 minus 13, and that'll equal our y-intercept of negative 624, which is a times 8 times negative 12 times negative 13 equals negative 624. If you multiply 8, negative 12, and negative 13, you get 1248. So we have a times 1248 equals negative 624. We divide, a is negative 624 over 1248, which simplifies to negative 1/2. So then our function is p of x equals negative 1/2 times, back up here to what we had, x plus 8, x minus 12, x minus 13. And that's it. So we have it in factored form. We're not asked to write standard form, so we're going to leave it, but we could multiply through and find it if we wanted to. For this next one, all we have is zeros. We don't have a y-intercept. So no y-intercept, so no a. The key is this is find just like a third degree polynomial, so one of them, versus when you have a y-intercept, you have the exact polynomial. So if we do this, we can just say p of x equals x minus 1 times x minus 3/5 times x minus a negative 2/3. Let's rewrite it. X minus 1, x minus 3/5 times x plus 2/3. But we need to rewrite these with whole numbers, just to be proper. It's not that it's wrong, but generally we like to have whole numbers. So if we do that, one moment, just switching colors. So basically, when we're doing this, let's say x minus 3/5 equals 0, right? Because it's a 0. To get rid of our denominator, we can multiply everything by 5. So 5 times x is 5x, negative 3/5 times 5 is negative 3, 0 times 5 is 0. So that equals our factor that we'll use. And notice that x equals 3/5 either way. If we look at x plus 2/3 equals 0, we can multiply by 3 to get rid of the denominator. 3 times x is 3x, 3 times 2/3 is 2, 0 times 3 is 0. And again, no matter which of these equations you look at, x is still negative 2/3. So we'll rewrite one more time. X minus 1 times 5x minus 3 times 3x plus 2. And there's our answer. And again, we don't have an a because we weren't given a y-intercept. So we would have to adjust this if we were given a y-intercept. Last piece of these notes, factor solution intercept equivalence theorem. That's lovely. I don't care what it's called, as usual. But for any polynomial p of x with real coefficients and some real number c, the following are logically equivalent statements. So these all mean the same thing. It means the same thing if you say x minus c is a factor. It means the same thing if you say p of c is 0, if you say c is an x-intercept of the graph, if you say c is a 0, or if you say the remainder when p of x is divided by x minus c is 0. So for example, like if you have some graph, it's probably cubic. Let's say this is the point 3, 0. So we could say that x minus 3, like 3 would be our c, okay? We could say x minus 3 is a factor of the function of the equation. We could say p of 3 is 0. We could say 3 is an x-intercept, 3 is a 0, or the remainder when you divide is 0, and they're all equivalent.